Good morning, everybody. I am starting my lecture series on anesthesia workstations. Now we come to the medical gas inlets. Medical gases, oxygen, nitrous oxide and air are supplied through the pipelines, which are connected to the machine through non-interchangeable connections. The standards for anesthesia workstation requires that every anesthesia machine has a diameter index safety system, that is DISS, fitting for each pipeline inlet to prevent the incorrect connections. All pipe suppliers have a backup cylinder supply. There is one or two E-type cylinders. The outlet portion of the cylinder is aligned with gas inlet nipple. A Botox cell is placed between the cylinder and the yoke, ensuring leak-free fitting. The assembly has a pin index system to prevent the incorrect connection of gases. Two pins on the machine should be aligned with the corresponding holes on the cylinder head. Inadvertent placement of two Botox cells may allow incorrect connections. Before mounting, the cylinder should be opened gently to blow away any dust in the hole and closed. The cylinder is securely mounted with a screw clamp. Applying the soap water to the junction and observing for any bubble formation can detect the presence of leaks in this area. Now, pressure gauges. All machines are equipped with bore pressure gauges to monitor the pressure in the cylinders and the pipelines. A flexible tube, that is Bourdon tube, within this gauge straightens when exposed to gas pressure. This motion is transmitted to a pointer through a gearing mechanism. In the modern machines, these gauges are located at the front panel of the machine. The dials carry two types of units of measurement of pressure: pound per square inch, the PSI, and kilopascals multiplied by 100, that is kPa multiplied by 100. Monitoring the pressure will ensure that there is adequate gas supply all times, and the pressure in the oxygen cylinder would give us an idea of the quantity of oxygen backup. The gauges on nitrous oxide cylinder do not give any indication of the amount of nitrous oxide in the cylinder, as nitrous oxide exists as a liquid. Now we come to the pressure regulator. Each gas supplied from cylinders to the machine must have a pressure regulator. Pressure regulators not only reduce the pressure of gases from cylinders but also provide the gases at a nearly constant reduced pressure in the flow meters. Despite the changing pressures in the cylinders, the reduced pressure nearly remains constant. Since pressure is defined as force per unit area, a high pressure acting on a small area can be balanced by a low pressure acting on a large area. A large diaphragm in the regulator. A simple pressure reducing valve constructed using this principle will, however, result in decreasing reduced pressures as the cylinder contains empty. In order to smoothen the flow and keep the reduced pressure nearly constant, a set of high force springs are added in the regulator. The pressure regulators on the anesthesia machines are factory preset to reduce the high pressure in the cylinders to 300 to 350 kPa or 45 to 50 psi. The pipeline pressures are supplied at a pressure of 350 to 400 kPa or 50 to 55 psi to ensure that the pipeline supply is used preferentially even if the cylinder is left open unintentionally. Some machines have second stage regulators in the intermediate pressure sections before the flow meters and oxygen flasks. The second regulator reduces the oxygen pressure further to approximately 20 psig for oxygen and 38 psig for nitrous oxide. This ensures the lower pressure at oxygen flasks, minimize the pressure fluctuation to the flow meter and hence maintain constant flow and decrease the wear and tear of needle valves of the flow meters. Two-stage regulators are also used in demand flow Entronox apparatus. Check valves. Check valves are present on the yoke after the fresh gas entry port to prevent the leaks during change of cylinders and to prevent the filling of cylinders from pipelines or the second backup cylinder even if the cylinders are inadvertently left in the open position. These are also present at the entry of pipeline to prevent the backflow into the pipeline to the in the event of falling pressure in the pipeline and backup cylinder is being used. A check valve is also present downstream of the vaporizer bank to ensure that back pressure is not transmitted to vaporizers, particularly when the oxygen flask is activated. Thank you. This much for today. In next video, I will come with more information.